The first challenge is web readme. It says just read the flag. It gives us a link. If we go there, it says 404 not found, and we're given a download. Within the download folder, we're given a Docker file. So just Golang, Alpine binary, a flag. It builds it, it runs it, nothing too exciting. And it's using Go version 1.19. Then there's this README file. If we just do a quick scan over it, we see something about a password. It's initializing some random data. There's a web route called just read it. It's going to parse some data, looks like some JSON. Looks like at the very end of this route, it's going to get the environment variable and give us the flag. So something with that route is important. There's a main function. Looks like it's going to initialize some random data. There's only one web handler, the just read it, the thing we just saw. It's going to create the server. It looks like we have a bunch of validation logic. It's reading from some IO streams, some validation, Golang contexts. Cool. So it looks like the goal is there's this one web route, and at the very end, if we can pass all this validation, we get the flag. Going back to the top, there's this init random data function. And so what this is going to do is it's going to seed the rand package. So it's a predictable random seed. Then it's going to read 24.5 thousand bytes from the random number generator here. And then it's going to insert into that large stream of random numbers this password object. And this password object is the SHA sum of idek. Now if we see if this password is used anywhere else, looks like it's being used later in this validate function. So at some point, it's going to read some data and compare a buffer with the password. So at some point, we will need that SHA sum. Interesting. Cool. If we look at the web route, it's going to read the body, unmarshal some JSON. This is the JSON structure. So we need to send a JSON payload of an array of integers with the key value of orders. It's going to check, make sure that the length of the orders is not greater than 10. Just put 10 here. Then it's going to read from that random data stream, or it's going to create a reader from the random data stream. So that's like the 24,000 bytes. It's going to create this validator object. It's going to do some validation on our integer. So it's going to go through all the orders, which are just ints. Then read. Some more validation. If we do all that, we get the flag. So the program really isn't too complex. I think probably the hardest part of this challenge was just trying to understand what all these validators and context things are doing. I'm not going to go through all the code. I don't think it's too insightful, but basically what's going to happen is there's that very large buffer of 24.5 thousand byte buffer of random integers. And we get to read from this stream. And we get to read the number of bytes in this order array that we're going to pass it. So we're only allowed to pass 10 orders, and the orders have to be between 0 and 100. And we're going to keep reading from this random data stream, and at the very end, it's going to pull off 32 bytes off of that random data stream and compare it with the password. But this challenge at first seems impossible because our maximum order size is 100, and we're only allowed to put 10 orders in there. So the most we could read is 1,000 bytes. And somehow we have to read this random data stream all the way to 12,000 bytes. So just doesn't seem possible. Like going through the logic, like I said, it's going to unmarshal the JSON. It's going to make sure we only have 10 orders. It's going to start that random data reader. So this is just the reader object. And from here, it's going to do that logic where it reads, 100 bytes at a time or so. This thing verifies to make sure that the orders, like I said, are between 0 and 100. One of the crucial steps that I missed the very first time I was looking over this code, and so this challenge took me quite a few hours, even though it is relatively simple, is if O is greater than 100, so O is allowed to be 100. And the last thing that really helps you solve the solution, again, it's doing a bunch of context stuff. Basically, Golang, if you're not familiar with Golang, Golang has this context object, and usually you use it for like canceling deadlines. Like if you have a request and maybe it's going to read to the database, but the original HTTP request is canceled or something, like you can use this context object to propagate like error handling and cancellation deadlines and stuff like that. And so the whole chain is canceled. It's not too exciting not necessary for this challenge. Instead, what you can also use these context objects for storing values. It's not necessarily a best practice, but you can do it. We're getting a little bit off topic, but you can see it doesn't have type information when you store objects on this context thing, which can lead to some issues. But this challenge didn't exploit that. All the types are correct here. But what was interesting about this is if the size is greater than or equal to 100 of one of our order objects, it'll create this buffered reader. And so this was actually the bug. So like I said, zooming back, there's this large buffer, and somewhere in the buffer at like index 12,000 is our password. And with each of the orders, we can read off of this buffer, but it seems like we can only read 100 bytes at a time. And so there's no way we're going to be able to read 12,000 bytes. So we get to the point where the password is on the buffer or at the head of the buffer. But thankfully this is buffered IO. Buffered IO, whenever you do a read on it, it's a buffered read, and it's going to fill the buffer from the reader. By default, Buffio, I think, is 4 kilobytes. And so if we were to create a size of 100, it'll create this buffered object. It'll read from that. And right off the bat, it's going to read from the underlying reader 4,096 bytes. So you only need a couple of these to get to index 12,000. So specifically, let's see, we need to get to this. So if we were to do, let's say 3 minus 3 reads of 496, you can see then we only have to read 337 bytes left. And so then if we were to do like a 99, we only have 139 left, minus 99, then a 40. And so if we were to send 3 orders of 100, it's going to do that buffered read. And so it'll read 4,096 bytes. And then if we were to do 99 bytes, 99 bytes, 99 bytes, and 40 bytes, the indexes will match such that password will be at the head of the reader object right here, because we keep reading off of this reader. And so once we do that, it's going to validate that the password equals password. And since they're like matched up on the buffer reader, it'll just pass and you get the flag. So once you see that, the solution's super simple. Request object, here's the host, here's the path, and then like I said, order. So we're going to do 100, 100, 100, 90, 90, 90, and then 40. And it should just work. Python 3 solve. Bam, and there's the flag. So fun challenge. Good to know that buffered readers automatically read 4 kilobytes. Thanks.